Good morning, dear students, and welcome back to this online class of chemistry. So in the last video, we discussed that what is the relationship between the molecular mass and vapor density. And today's topic is percentage composition, empirical and molecular formula. So let's start our topic. So first we discuss what is percentage composition. Okay, percentage composition of a compound is the percentage its weight, okay, of each element present in that molecule of a compound. Clear? That means what is percentage composition? That means the percentage composition of a compound gives that relative amount of each element present in the molecule of a compound. So what is the formula? That percentage of an element in a compound equal to the total weight of element in one molecule divided by gram molecular weight of the compound into 100. That means what is that formula? The percentage equal to percentage of an element equal to mass of the element divided by mass of the compound into 100. Okay. So already you know that the sum of that percentage of each element in a compound should be how much? You have to get 100. Okay. That means if you add, for example, Na2CO3, sodium carbonate, when you will be add, you have to get that how much? That equal to 100, that atomic mass. Okay. So let's see one example how to calculate that percentage composition of an element in a compound. See here, find the percentage by mass of oxygen in water. That means see, first what is that formula? First you have to find out what is the molecular mass of water. Okay, molecular mass, hydrogen, what? 1. How much atoms are there? 2. 2 into 1, 2. Oxygen, how much atoms are there? 1. And molecular atomic mass equal to 16. Then 16 plus 2 equal to 18. So what is the molecular mass of water? That equal to 18. Now I have questioned that what is the percentage of oxygen in water? So let's calculate. What is the formula? That equal to mass of an element divided by mass of compound into 100. Here mass of an element equal to how much? 16 divided by 18 into 100. That equal to 88.9%. That means here what is how much oxygen is there? 88.9% of oxygen in water. Clear? The next one, see, you have to find out another example. See here, the percentage of carbon in carbon dioxide, okay, or percentage of oxygen in carbon dioxide. That we discuss. What is the first step? That we have to calculate the molecular mass of carbon dioxide, and we know that how will you calculate the molecular mass? That carbon equal to atomic mass of carbon equal to 12 and oxygen equal to 16. Here how much oxygen are there? That is equal to 2. 2 into 16, that equal to 32. 32 plus 12, that equal to 44. Okay. That means molecular mass of carbon dioxide equal to 44. Now you have to calculate what is the percentage of carbon in carbon dioxide. Okay. So what is the formula? Formula equal percentage of carbon equal to, that is atomic mass of one carbon divided by molecular mass of what? Carbon dioxide into 100. Then therefore see, atomic mass of carbon equal to 12 divided by molecular mass of carbon dioxide 44 into 100. That equal to how much you get? 27.3%. Clear? Then you have to calculate what is the percentage of oxygen in carbon dioxide. So here you see what is the percentage of oxygen. Like similar way you have to calculate that that equal to atomic mass of oxygen, that equal to how much here? Because oxygen is 2, that means 16 into 2, that equal to 32 molecular mass, and molecular mass of carbon dioxide equal to 44, that for 32 by 44 into 100, and you have to get how much? 72.7%. Another way also you have to calculate oxygen. See here, you have to get that what? You know that the sum of that carbon dioxide equal to how much? Sum of the atomic mass equal to 100. Okay. Here you have to get 27.3%. Then 100 minus 27.3%, then you have to get also 72.7%. Okay. Like that also you have to calculate the percentage of oxygen. So next topic is our empirical formula and molecular formula. So first we discuss that what is empirical formula and molecular formula. Here you remember, empirical formula means that is the simplest way, that is shortest form, okay, shortest formula, and empirical formula means the true formula, that means it has the actual number of element, okay. So what is empirical formula? Empirical formula represent the smallest ratio of atoms present in a compound, okay, that means the smallest ratio. But molecular formula means what? It gives the total number of atoms of each element present in one molecule of a compound. And but empirical formula means the smallest ratio. That means smallest number of elements are present in that molecule of a compound. But molecular formula means that actual number of element present in that molecule of a compound. So let's see how will you calculate that empirical formula. Okay. So let's see here. Example, what is the empirical formula of H2O2? That means what? Hydrogen peroxide. The formula is H2O2. So to find that empirical formula, what is the formula? First you have to find out that smallest number. Okay. Here H2O2. What is the smallest number? That is 2. So you divided by 2 of each number. Okay. 2 1 is 2 and 2 1 is 2. That means you have to get what? HO. So the empirical formula of H2O2 equal to HO. Okay. See, like this other example are here. You have to find C6H6. Then what you do? C6 is the smallest number. 6 1 is 6. 6 1 is 6. Then empirical formula is CH. So the empirical formula of C6H6 equal to CH. Okay. Then second one, C6H12O6. That means 6 number of carbon, 12 number of hydrogen, 6 number of oxygen. Here 6 is the smallest number. The 6 1 ja, 6 2 ja, 6 1 ja. So what is the empirical formula here? CH2O. Okay. See third one, C4H8. Okay, 4 is the smallest number. So you divided by 4. If each number carbon atom is equal to 4, hydrogen equal to 8. So 4 1 ja, 4 2 ja. That empirical formula of C4H8 equal to CH2. And here you see H2O. Okay, H2O. Here the empirical formula also same. So what you find? Empirical formula and molecular formula may be same also. That means not in the every case not it is different. Okay, if you are getting that whole ratio, then you have to find that the empirical formula. Otherwise you have to write that the same ratio, no, same formula. Then see next one is C4O8. Okay. So you have 4 1 ja, 4 1 ja, 4 2 ja, that means HCO. Here what is written? H2C2O4, then again 2 is the smallest number, 2 1 ja, 2 1 ja, 2 2 ja, that means HCO2. Okay. The next one P4O10. Okay, that smallest number you have to find out here, that means 2 2 ja 4. How you will divide? You have to get a simplest ratio. That means 2 2 ja 4, 2 5 ja. So what is the empirical formula of P4O10? That equal to P2O5. The next one CaOH whole twice, calcium hydroxide, that equal to what? CaO2H2. Okay, that empirical formula of calcium hydroxide, CaOH whole twice, that equal to CaO2H2. Like this NH4 whole twice CO3, that is ammonium carbonate, that equal to N2H8CO3. And magnesium nitrate MgNO3 whole twice, that equal to magnesium MgN2O6. Okay. So like this you have to calculate that empirical formula from that molecular formula. Let's see another example. Here you see the empirical formula. How will you calculate? See, this is the lowest whole number ratio the elements in a compound. For example of molecular formula of C6H6. Then you have to write CH because C1 6 1 ja 6 1 ja. Then second one, see what is the empirical formula for each? You have to find out. See C2H6. What is the empirical formula? 2 1 ja 2 3 ja. That means CH3. Okay. Then next one, see C6H12OC. What is the empirical formula of C6H12O6? That is 6 1 ja, 6 2 ja and 6 1 ja. That means CH2O. Okay, CH2O. Empirical formula of C6H12O6 equal to CH2O. So now you have to calculate. Like this you have to calculate that empirical formula from the molecular formula. Okay, now we have to given that some percentage of each atom. Then how you have to calculate that? See here another example. Here you see that see here that H2O you know that empirical formula remaining same. Then see next one is what? That means the molecular formula and the empirical formula may be identical, or the empirical formula and molecular formula may be same also. Okay. See, this is the example. Here you see C2H4O2. That means what? 2 1 ja, 2 2 ja, 2 1 ja. That means the empirical formula equal to CH2O. Okay. And CH2O. That means here you can find out, see, that's empirical formula also remaining same. And that C6H12O6, that is CH2O. That means what you find here? The molecular formula, empirical formula may be same or it may be different. Okay. Then now we have to find out how empirical formula. Okay. From that to the compounds with the following, that means percentage of that compounds is given, percentage of that element is given. Now we have to calculate that empirical formula from that percentage of that element. So see here how will you calculate? Here you see given that the compound contains that 32.38% of sodium and 22.65% of sulfur and 44.99% of oxygen. So from this percentage you have to calculate that empirical formula. So what is the formula? Here you find out, see, what are that element given here. See, first you write in one column that element name. So what are the element here? First one is sodium, okay. Then second one is sulfur, okay. And third one is oxygen. So in the first column you have to write that element names. After that, in the second column you have to write what? The composition. What are the composition given of that element? So in the second column what is right? That is percentage of sodium. Okay. What is given here? 32.38. Then second one is the sulfur. Percentage is given 22.65. And oxygen, the percentage is 44.99. Okay. So after that what you write? That you have to calculate that atomic mass of that element. Here that atomic mass of the next column. Okay. And the atomic mass of element is what? How much? That equal to sodium. Sodium equal to how much? That equal to 23. Okay. And sulfur equal to, you know, 32. And oxygen equal to 16. Okay. Then after what you write? That means you have to calculate that ratio. Okay. Atomic ratio. That means the percentage composition, okay, divided by that atomic mass. The next column what you write? That atomic ratio that equal to percentage composition here equal to how much? 32.38 divided by 23. Okay. Then you have to get 1.408. And next one, see, that equal to sulfur. Sulfur equal to how much you got? You have, that is percentage given 22.65. Okay. And atomic mass equal to 32. Then you have to find out when you divide 0.708. Okay. And oxygen percentage is given 44.99. Okay. And what is the atomic mass of oxygen? That is 16. When you divide, you have to get 2.61 and 2.812 of oxygen. Okay. That means number of moles present in that compound. Okay. So after that, when you divide, you have to find out that the smallest number. Okay. Here you have to see how much you get. 1.408, 0.708 and 2.812. So here, which is the smallest number? That equal to 0.708. That means what is the atomic ratio you have given? You have find out the smallest number and divide by each number. Understood? That means 1.408 divided by 0.708. Then 0.708 divided by 0.708 and 2.812 divided by 0.708. Then how much you get for sodium? For sodium, when you divide 1.408 divided by 0.708, you have to get how much? 2. Okay. that is C 2, and 0.708 by 0.708 that equal to 1, and oxygen that equal to 2.812 divided by 0.708 that equal to 4. That means you have to get 2 sodium, 1 sulfur and 4 oxygen. So what is the empirical formula now? Now you have to write, see what is the empirical formula? Empirical formula equal to sodium Na2, okay? How much you get sodium? Answer is you get the 2. So Na2 and sulfur equal to how much? 1. So Na2S and oxygen 4. Na2SO4, that is sodium sulfate. Okay? So you write that Na2SO4. The empirical formula equal to Na2SO4. Clear? Like this you have to find out that empirical formula from when it is given that percentage. Okay? The next one, see here. See that formula is Na2SO4. The next one, see one more example you have to find out. See how will you find out that molecular mass? Okay, that is molecular formula of the compound. So let's discuss. One question is given. See here, a compound is found to possesses that carbon equal to 40% and hydrogen equal to 6.7%, oxygen equal to 53.3%. So its molecular mass is given, and you have to find out what? Empirical formula and molecular formula. Find the molecular formula. Here percent is given. That means you have to find out that empirical formula first. Then after molecular mass is given, you have to find out how to find out that what? Molecular formula. So here first, in the similar way you have to calculate that what? Empirical formula first. So the first column you have to see, first column what you write here? Element, that is carbon, hydrogen and oxygen. In the second column what? Percentage composition, that equal to carbon equal to 40, sulfur equal to, hydrogen equal to 6.7% and oxygen equal to 53.3%. Okay. So here you written the third column what you find? You have to write that atomic mass of each element, that is carbon equal to 12, hydrogen 1, oxygen 16. Then after what is the next column? Atomic ratio. Okay, atomic ratio means what? Percentage divided by atomic mass. Here what you write? That equal to 40 by 12, that equal to 3.3. Then next one 6.7 by 1, that equal to 6.7, and 53.3 by 16, that equal to 3.3. That means what? After that in the next column what you find? The simplest ratio. Okay, so here you have to find out that the smallest number, and here is the smallest ratio, smallest number equal to what? That equal to 3.3. Okay, see here carbon 3.3 and oxygen also 3.3. Then after you have to divide it by 3.3 by each number. Okay, then 3.3 divided by 3.3, that equal to 1, and 6.7 divided by 3.3, that equal to 2, and 3.3 that nearly equal to 2. Okay, and 3.3 by 3.3, that equal to 1. Okay, so after that the empirical so here now carbon how much you get? 1, hydrogen 2 and oxygen also 1. So the empirical formula you write C equal to how much? 1, that's C, and oxygen hydrogen 2, then CH2 and oxygen 1, that equal to O. So the empirical formula is equal to CH2O. Now you have to find out that mass, empirical mass. Okay, see here the molecular formula of the compound CH2O, that equal to N equal to what? Carbon equal to 12, okay, and hydrogen equal to 2 because 1 into 2, and oxygen equal to 16, that equal to 18. Okay, that 16 plus 2 18 and plus 12, that equal to 30. Understood? That is equal to what? Molecular mass of empirical formula. Molecular mass of empirical formula, that you have to get 30. And now you have to calculate what? Molecular mass. Molecular mass is given how much? 60. And now you have to find out what? Molecular formula. So molecular formula equal to what? Here is what you would do, that is 30 and is you have to find out what? Molecular mass of empirical formula. Okay, molecular mass is given. Molecular mass equal to N is equal to how much you got? That equal to 30, 60 by 30, that equal to 2. That N equal to you have to get 2. Okay, so now the molecular formula you have to get that what? N formula is what? CH2O, N in bracket what? CH2O, that means N equal to 2. That means C2H4O2. Okay. So like this you have to calculate that empirical formula and molecular formula. Thank you.